So we're going to focus on domain and range, and these are some really specific representations of coordinates on a plane. So the very first one here, they've kind of just drawn two vertical loops. Think of them as like columns, and they have values. And actually, I should specify this is an x value and this is a y value. So what they're saying, this is two-dimensional plane. Technically, you can have more. So we're talking about this, like our x and our y grid, and you'll see that the x values or y values can have more than one other coordinate associated with it. So -1 has -1, 2 and -1, 4. So what does that mean? Well, let's say this is -1 and this is 1, 2, 3, 4. -1 has a coordinate at -1 and 2, and it has another coordinate at -1 and 4. So these are two coordinates right there, okay? 1 has a coordinate of 1, 5, so let's say this is 1 here, and 5 is probably about there, so that's two of the coordinates. And finally we have 3, 2, 3 is probably about here. Okay, so we now have 1, 2, 3, 4, so we know there are 4 coordinates here, okay? Domain deals with the x values of anything. So our domain in this one, we might write D, colon, and we would just literally write out what our x values are. Well, our x values here are -1, 1, and 3. The range here would be 2. Whoops, that's not a 4. Let's just kind of over it. There we go, 4 and 5. That's our domain. That's our range. Sorry, I should have said deals with y. That's all it is to those two. Very, very simple. Now, one thing they might ask you to do is to tell if something is a function. And a function can't have two y values for the same x value. Okay, so right here we have two coordinates, two y values for that x value, so they're stacked on top of each other. That would tell you that this is not a function. That's just a quick tidbit, because sometimes they'll ask a question where they'll put it in this style, and they'll say, is this a function? And as soon as you see an x value that has two different y values, that means it can't be. You can have multiple, like this number 2 could have -1, 2, 1, 2, 3, 2. That's fine, because you just have a bunch of coordinates like written across like this. The other way to do it is to set it on a graph, and if anything's vertically stacked, it's not a function, okay? Same idea with here. They've given you the coordinates. They'll ask you what the domain and range is. Let's do domain in red, and I'll change range there. So domain here, all I'm doing is taking the x values. We normally write them in like a numerical order. So we have -3, -2, 5, and then 6. So -3, -2, 5, 6. Okay. Range, it's all the y values. So we have 2, 3, 5, 6. 2, that's terrible, 2, 3, 5, 6. If perchance we had another coordinate, let's say, and it said -2, yeah, sure, -2, and actually, before I do that, first thing I want to ask you is this a function? Right, looking at it.
Yes.
Yeah, none of our x values kind of double up. There's not two representations of it, so this is a function, so we would say yes. Good. Now, let's say I add this coordinate to it, 2, 5. Is this a function now?
No.
No, we have a double up on the -2. But our domain and range, even if I add this coordinate to our representation, because -2 is already represented in the domain and 5 is already represented in the range, nothing has changed. We don't write it twice. We wouldn't write -3, -2, -2. -2 is already there. We know that's a coordinate. 5 is already there for range. We know that's a coordinate. Okay? These are really specific for just coordinates. But let's say we're talking about... I'm going to switch over to Desmos for this. Let's say we're talking about these. These are quadratics here. Okay? I lied. I don't want to do that yet. Switch over to this page. Let's say we have... Oh, I want it to be like that. There we go. We can have a linear function, y equals 3x plus 2. We could have a quadratic function, y equals 3x squared plus 2x plus 1. Okay? Just the general idea, let's say I was to sketch this out. It's about 2, it's got a decent slope to it, and it goes on forever. Okay? A linear function has a domain The domain is technically, they'll write it like this. X is the element of all real numbers. All that means is this function is going to go left and right forever. It's also going to go, the range is y is the element of all real numbers. That means it's also going to go up and down forever. Nothing stopping this function. So we represent it. R stands for real numbers. Real numbers are any single number that's like decimal values that go on infinitely, things like that. It represents all numbers, okay? Quadratics, I chose a bad one because I, off the top of my head, I can't tell you where the vertex of this is. But I'm just going to take a wild stab out of here. I'm going to pretend the vertex is there, okay? I know that's not right. Quadratic, pretty close. It's very similar. The domain of a quadratic is, it's going to go to the right forever, and it's going to go to the left forever. So we write domain is x is the element of all real numbers. Nothing changes there. But our range here, a little different. This quadratic is going upwards, so it's definitely going to go towards infinity. So we would still say y is the element of all real numbers. And then we would draw a vertical line. This represents such that, they would say. And this is important, what's happening there. Okay? Let's just say that's at positive 2. It touches positive 2, but it never goes below it. So we say y is all numbers where y is greater than and equal to 2. And then sometimes they represent it with like this little set of curly brackets around it. I should have done that around all of them. So we say y is absolutely every number greater than and equal to 2. So that's what this one. This covers everything because it's continuous. It's not little points.
You have to add that before. You have to.
So when we write it, that tends to be the way you would write it in mathematical notation. Now, when we switch to Desmos, you're going to notice that this is actually not needed in Desmos. It's actually like assumed, and we just have to write this part. And this is the part that becomes really important in Desmos when we're cutting our functions. Okay, so get rid of those x's because I don't want you to think they're wrong. When we go into Desmos here, I have two quadratics, okay? Now, first of all, let's say I want to get it to touch this Flappy Bird here. The first quadratic I have is blue. It's going upwards. I need it to get wider. So I need that A value, the value in front, to be less than 1. So I'm going to say 0.5. Oh, yeah, that almost gets it. 0.6. Nope, sorry, that one's smaller. Nope, that one's smaller again. 0.25. Ooh, close. 0.3. Yay, there we go. Okay, I'm going through the bird. And it's going down, going down, going down. And I need to hit my next function, my next quadratic. My next quadratic is actually too wide. I'm going to thin it out a little. Hey, that works out perfect. Awesome. So I got a coordinate here, a really random decimal value. But that's where they intersect, and that'll be great. I want these two things to intersect here. But I need to cut this function, okay? Because I want this to look clean. I want it to look like the trajectory of the bird. I don't want it to just look like a bunch of quadratics cutting through, because it also cuts through here, so I'm not sure where I want to stop. So to write here, we can write either domain or range, okay? It just depends whether I type in the letter X or the letter Y. So I'm going to put in this set of curly brackets, okay? And on my X, I'm just going to hold down here. It's hard to see, but I have like 2.25. It's hard to see there.
Oh, yeah.
Yeah, that's the X value of the bird. So I'm going to say 2.25 greater than or less than X. So right away, did you notice the function got cut to the left? Okay, I'm saying X is greater than or equal to that value. Great, so it's not showing me anything to the left of that anymore. And I would like it to stop at 4.817. I'm reading the X values here, okay? So I then say, so it says X is greater than 2.25, but is also less than, I already forgot, 4.817? I think that was right. Yeah, I got it. So perfect, cuts it off right at the next quadratic. So you'll notice I cut it off by domain. Think of this like two vertical lines that have sliced everything. And I'm going to write them in right here. X equals 2.25. Think of it like a vertical line that cut the quadratic. And anything to the left of it is gone. And it's another vertical line. X equals 4.817. Another vertical line that cut everything to the right of quadratic. Okay? That's what we're doing with those two there. I could have, I'll turn those off. I could have done the same thing. I think I can duplicate these things. I just forget how. Duplicate. Oh, I don't forget. Yeah. I'm going to change this to, I'm going to see a very big change in this quadratic here. Ready? Y. Oops, it didn't do anything. There we go. First of all, it's telling me I need to turn this into an equation. Oh, yes. In order to do y, I must say y equals, because there's no y in this equation. So I do need to say that. Because I had an x before, it accepted me not writing y equals, but once I go to cut by range, I have to have a y in the equation. Now look at this quadratic. This is very different. You'll notice what's happened here is, can I touch that part? About 4.18, yeah. So y is greater than 2.25. Why does that feel off to me? And less than 4.48. This should have cut it, I feel like. It did, right there. Oh, that's why I have two of these turned on. There we go. Good. I was getting a little confused. So this quadratic, if you notice, I'm going to turn the other one on. That's what it's supposed to look like. Because I've done it in y, think of them as horizontal lines that have cut this. So now I have y equals 2.25. So a vertical line has sliced the quadratic. Nothing below it is showing up. And y equals 4.817. It's also sliced the quadratic. Did I write it wrong? Oh yeah, I did. 817. Another, did I say vertical? I meant horizontal line has cut this quadratic and nothing is above that. So you can kind of slice things with vertical or horizontal lines. In the case of this, going by horizontals doesn't really work so well, right? Because, I'm going to turn these two off. I'm going to turn this one off and this one back on. I actually want different heights. I want the bird to be higher here and lower there. So using the domain is a much better way to cut this thing off. In this one here, same concept. I would cut it off by domain again. So I'll put my curly brackets around it. That's not a curly bracket. There we go. I'm going to say we need, what's the x value here? Oh, it should be the exact same as the last one we stopped at. So 4.817. 17 less than and equal to x. Perfect. It sliced it. Kind of mess. Mine's a little too wide here. I'm going to cut it off somewhere here. Looks like that's around 6.5. So I'm going to say less than and equal to 6.5. And now let's cut my quadratic. Okay, so all it does is kind of clean it up here. But what it's really saying is a function exists within these parameters. Domain and range give you parameters for something. Okay? All right.